Hello everyone. In this video, I'll complete solving the last part of the ministerial question of lesson 4.4 curve sketching in the book of ministerial questions. We reach question number 41. Question number 41. By using symmetric asymptote intercepts first and second derivative test, find the graph of the function f of x equal 1 minus x power 2 over x power 2 plus 1. As you see, the degree of the numerator is 2 and the degree of the denominator is also 2. So we have a horizontal asymptote at -1, the coefficient of the leading term in the numerator -1 over the coefficient of the leading term in the denominator 1, -1 over 1. So we choose C and B and C. A and D are wrong because the graph has no horizontal asymptote at -1. In the graph of C, y-intercept at 1, if we substitute every x with 0, then 1 minus 0 over 0 plus 1 equal to 1. So the right choice is C. But at B, we have y-intercept and x-intercept at 0, 0 that is not satisfied with the function. So the right choice is C. Question number 42 also use the symmetric asymptote intercept first and second derivative test to find the graph of the function f of x equal 1 over x. As you see, the degree of the numerator is 0 and the denominator is 1. So we have a horizontal asymptote at x equals 0. All the four graphs are true. Also, the function is odd since we have even over odd. So we neglect A and B because these graphs are even. So either C or D is the right choice. As you see, when x equal 1, f of x also equal 1. If we substitute every x with 1 over 1, 1. But here when x equal 1, f of x is -1. So this choice is wrong. The right choice is C. Question number 43, f of x equal 2x over 1 plus x power 2. As you see, the degree of the numerator is 1 and the denominator is 2. So we have a horizontal asymptote at x equals 0. All the four graphs are right. But the function is even since the function is odd since even times odd over even plus even odd over even, odd. So I neglect C and D because the graph of these two choices is even. Now, when x equal 1, in A, when x equal 1, f of x equal -1, let us substitute 2 times 1, 2 over 1 plus 1 square, 2, 2 over 2, 1. But here is -1, so this choice is wrong. The right choice is B. 2 times 1, 2 over 1 plus 1, 2, 2 over 2, 1, f of 1 is 1, so the right choice is B. Question number 44, f of x equal 1 over x minus 1. As you see, the degree of the numerator is 0 and denominator is 1, so we have a horizontal asymptote at x equals 0. All the four graphs are right choice, and we have a vertical asymptote at x equal 1 since 1 makes the denominator 0. So we neglect A and D because the graph don't contain or don't have a vertical asymptote at 1. Now, in B, we have a y-intercept at 1. If we substitute every x with 0, y should be 1. 1 over 0 minus 1 is negative 1. So this choice is wrong. But here we have a y-intercept at negative 1. When you substitute every x with 0, y is negative 1. 1 over 0 minus 1, 1 over negative 1, negative 1. So C is right choice. Question number 45. F of x equal x plus 1 over x minus 1. We have a vertical asymptote at 1 since 1 make the denominator 0. So A is possible right choice, B is not, C is possible right choice, D is not. So the right choice is either A or C. Also, we have a horizontal asymptote at 1 since the leading term in the numerator is 1, the coefficient of the leading term in the numerator is 1, and the coefficient of the leading term in the denominator also is 1, and the degree of numerator and denominator are equal. So 1 over 1, 1. So y equal 1 is a horizontal asymptote for this function. So we have A, but C, the horizontal asymptote is y equal negative 1, so it's wrong. The right choice is A. Question number 46. Also by using symmetric asymptote intercepts first and second derivative test, find the graph of the function f of x equal x times x minus 4 all power 3. As you see, the function is neither. We have two x-intercepts. If we set y equals 0, then x times x minus 4 to the power 3 equals 0. Either x equals 0 or x minus 4 to the power 3 equals 0. This gives you x minus 4 equals 0, then x equals 4. So we have two x-intercepts at 0 and 4. So the right choice is either C or D, but not A or B because the x-intercepts here is negative 4 with 0. Also, f of 1 in C is 27, f of 1 in D is negative 27. If we substitute 1 in the function, we will get 1 times 1 minus 3 to the power 3, negative 3 to the power 3, negative 27. So the right choice is D. F of 1 is negative 27. Question number 47. F of x equal x power 4 minus 2x power 2. The function is even and all the four graphs are even. But if we want to find the x-intercepts for this function, we set y equals 0, then 0 equal x power 4 minus 2x power 2. Factorize by x power 2, x power 2 minus 2 equals 0. Either x equals 0 or x equal negative positive square root 2. Square root 2 is negative positive 1.4. Now, here the x-intercepts are negative 1 and 1, so this is wrong. We have A, C, and D. Maybe one of them is a right choice. Now, f of 1. If we find f of 1 in the function 1 minus 2, negative 1. Here, f of 1 is negative 1. And f of negative 1, negative 1 to the power 4, 1 minus 2, also negative 1. So this choice may be true. But if we substitute here 1, then f of 1 is less than negative 2. So this is wrong. Here, f of 1 is 1 is also wrong. We want f of 1 is negative 1. The right choice is A. Question number 48. F of x equal 1 minus x power 2 over 2x. The function has slant asymptote since the degree of the numerator is 1 more than the degree of the denominator, and there is no common factor between the numerator and denominator. The slant asymptote is 1 over 2x minus 1 half x. So we have a slant asymptote with a negative slope, either A or D. Now, in A, we have two x-intercept point, -1 and 1. Let us find the x-intercepts from the function. We set 1 minus x power 2 over 2x equals 0. Then 1 minus x power 2 equals 0. Then x equals negative positive 1. So the right choice is A. But D, the function has no x-intercept, so it is wrong. Question number 49. F is a function whose derivative is decreasing function. Sketch the graph of a function where f prime of x greater than 0. F is a function whose derivative is decreasing. Here the function is decreasing and the derivative is increasing, so it is wrong. The function here, the derivative of the function here is increasing and greater than 0. This is the right choice. Here, the function in blue is decreasing and the derivative is also decreasing, and f prime is less than 0, not greater than 0. Choice D. The function in blue is increasing and the derivative also is increasing, but we have the derivative decreasing, so it is wrong. The right choice is B. Question number 50. Which of the following is false depending on the graph on the right? F of -2 equal to f of 0 equal to 1. F of -2 is 1. F of 0 also is 1. This choice is true, not false. F prime of x greater than 0 when x greater than -1. When x greater than -1, from -1 to infinity, the function is increasing. Therefore, f prime of x is greater than 0. So this choice also is true. F prime of -1 equals 0. F prime of -1 is undefined since the graph has a sharp vertex at -1. So this choice is wrong, is false. It is the right choice. Let us see choice D, f prime of x less than 0 when x less than -1. When s less than -1, from negative infinity to -1, the graph of the function is decreasing and therefore the derivative of the function is less than 0. It is also true. Therefore, the right choice is C. Question number 51. On which interval is the graph of f concave? As we see, the graph of f of the function is if convex from negative infinity to -2, concave from -2 to positive infinity. Therefore, -2 to positive infinity is the right choice. Question number 52. On which interval the graph of the function is concave? The graph of the function is convex from negative infinity to -1, union 1 to positive infinity, concave from -1 to 1. Therefore, the right choice is C. Which one is false depending on the graph on the right? F of -1 greater than 0. F of -1 is positive value, as we see here. So this choice is true. F prime of 0 equals 0. This is 0. And f of 0 is local minimum value, and the function has a horizontal tangent at this point. Therefore, it is critical value. Therefore, f prime of x is f prime of 0 equals 0. Also, this choice is true. F prime of 1 greater than 0. F prime of 1 is greater than 0 since the function is increasing from 0 to 2. Therefore, also this choice is true. If double prime of 2 greater than 0, as we see at 2 the function is convex, and therefore if double prime should be negative, less than 0, therefore this choice is wrong. It is the right choice. This statement is wrong, so it is the right choice. Question number 54. At what value of x is f double prime of x is negative? If double prime of x is negative when the graph is convex, and the graph is convex in the interval 0 to positive infinity, and concave in the interval negative infinity to 0. Therefore, the right choice is 0 to positive infinity. Choice B. Question number 55. Which of the following curves achieve the following? Let us check one by one. F of 2 equal to f of 0 equal to 0. As you see, 0 and 2 are x-intercepts for this graph. Therefore, this statement is true. F prime of x greater than 0 when x greater than 1. When x greater than 1, the function is increasing. Therefore, the derivative of the function is positive, greater than 0. F prime of x less than 0 when x is less than 1. When x is less than 1, the graph is decreasing. Therefore, the derivative of the function is less than 0. Therefore, this statement is true for the first graph also. C, f prime of 1 equals 0. As you see, at 1, the graph has a vertex, a sharp vertex point. Therefore, the derivative of the function of this function is undefined at 1. So this statement is not achieved to this graph. So choice A is wrong. Let us see choice B. 0 and 2 are two intercepts point for this graph. Therefore, the first statement is true. F prime of x greater than 0 when x greater than 1. When x greater than 1, the function is decreasing. Therefore, f prime of x should be less than 0. Therefore, statement B is not achieved with the second graph. Let us see graph C. 0 and 2 are two intercepts point for this graph. Therefore, the first statement is true. F prime of x greater than 0 when x greater than 1. When x greater than 1, the function is increasing. It is true. Therefore, the derivative is greater than 0. And when x less than 1, the function is decreasing. Therefore, f prime of x should be less than 0. Also, this statement is true. F prime of 1 equals 0. This is 1. The function has horizontal tangent line at 1. Therefore, 1, x equal 1 is a critical value for this graph, and this statement is true. F prime of 1 should be equal 0. If double prime of x greater than 0, since the graph is concave, therefore the second derivative is positive everywhere, where from negative infinity to positive infinity. Therefore, the right choice is C. Let us check the last one. 0 and 2 are two intercepts point. The first statement is true. F prime of x greater than 0 when x greater than 1. When x greater than 1, the function is decreasing. The graph of the function is decreasing. Therefore, the derivative should be less than 0. It is wrong. The right choice is C. Question number 56. Which of the following curves achieve the following statements? Let us check. The first statement, f of 2 equal to f of 0 equal to 0, it is true since 0 and 2 are two intercepts value for this graph. F prime of x greater than 0 when x less than 1. When x less than 1, f prime of x, the graph of the function is decreasing, and f prime of x should be less than 0. Therefore, this choice is wrong. Let us see B. 0 and 2 are two intercepts point. The first statement is true. F prime of x greater than 0 when x less than 1. When x less than 1, the function is increasing, therefore f prime of x is greater than 0. And when x greater than 1, f prime of x is less than 0 since the graph of the function is decreasing. Therefore, B is true also. F prime of 1 equals 0. At 1, the graph has a horizontal tangent line and local maximum value. Therefore, it is critical point at x equal 1 and the derivative should be 0. Therefore, this statement is also true. If double prime of x less than 0, since the graph of the function is convex, therefore the second derivative is negative everywhere. Therefore, the B is the right choice. Let us see C. 0 and 2 are two intercepts points for the graph. The first statement is true. F prime of x greater than 0 when x less than 1. When x less than 1, the function is decreasing. Therefore, f prime of x should be less than 0, not greater than 0. So this choice is wrong. The first statement is true since 0 and 2 are two intercepts value for this graph. F prime of x greater than 0 when x less than 1. When x less than 1, the graph is increasing. The statement is true. F prime of x less than 0 when x greater than 1, the graph is decreasing, also is true. F prime of 1 is 0. F prime of 1 is undefined since the graph has a sharp vertex value at 1. Therefore, this statement is also wrong. The right choice is B. Question number 57. Which of the following tables achieve the graph of F? Let us check one by one. When x equals negative 2, this is negative 2. F is positive, it is true. F prime is 0, since the graph has a horizontal tangent line at negative 2. Therefore, f prime of negative 2 is 0. F double prime is negative, since the graph is convex. Therefore, f double prime, the second derivative should be negative. When x equals 0, this is 0. F is 0, it is true. F of 0 is 0, as we see. F prime of 0 equals 0, since the function has a horizontal tangent line and 0 and 0, 0 is local minimum value for this function. It is true. F double prime of 0 is positive. F double prime of 0 is positive since the function is concave, also is true. At x equals 3, f is positive, it is positive, true. F prime of 3 equals 0, it is true since the function has a horizontal tangent line at 3. F double prime of 3 equals 0, it is also true since at x equals 3, the graph of the function has an inflection point. Therefore, x equals 3 is a critical value for this function. Therefore, this choice is true. Let us check B. At x equals negative 1, f is positive. At x equals negative 2, x is positive, true. F prime is 0, it is also true. It is critical value. F double prime is convex, also it is true since the graph is convex. At x equals 0, f is 0, f of 0, 0 belong to the graph. If a prime of 0 equals 0, also it is true since 0, 0 is local minimum value. If double prime is positive, it's also true since the function is concave. X equals 3, f is negative, it is wrong since f of 3 is 2, it is positive. Therefore, this choice is wrong. Let us see choice C. At x equals negative 2, positive, 0, positive. If double prime is positive at negative 2, it is wrong since the function is negative and since the function is convex. So f double prime of negative 2 should be negative. Therefore, this choice is wrong. The last choice, at x equals negative 2, f is negative. It is also wrong since f of negative 2 is 2 positive. Therefore, this choice also is wrong. The right choice is A. Question number 58. Which of the following is true depending on the graph? F of 1 equal negative 1. F of 1 is negative 1. It is true. F prime of 0 less than of f double prime of 1. F prime of 0 is positive value since the function is increasing, but f double prime of 1 is 0 since the function has an inflection point at 1. Therefore, this statement is wrong. Therefore, A is not the right choice. B, f of 1 equal negative 1. It is true, this statement. We check it in choice A. F prime of 0 less than f double prime of 1. It is wrong, as we see in choice A. Choice C, f of 1 equal negative 1. It is true. F prime of 0 greater than f double prime of 1. It is true since f double prime of 1 is 0 and f prime of 0 is positive value. F double prime of x less than 0 where x greater than 1. Where x greater than 1, the function or the graph of the function is concave and f double prime of x should be positive, not negative. Therefore, this statement is wrong. C is not the right choice. D, f of 1 equal negative 1. It is true. F prime of 0 greater than f double prime of 1. It's also true. F double prime of x greater than 0, positive, where x greater than 1. Where x greater than 1, the graph is concave and f double prime should be positive. It is true. F double prime of x less than 0, negative, where x less than 1. Where x less than 1, the graph is convex and f double prime should be negative. It's also true. The right choice is D, which is false for the graph on the right. F prime of negative 1 less than 0. At negative 1, the graph of the function is decreasing and f prime of x should be less than 0. It is true. It is not the right choice. F prime of 0 equals 0. F prime of 0 is 0 since the function has horizontal tangent line and local minimum value at x equals 0. So x equals 0 is critical value for the function, and this statement is also true. So it is not the right choice. F double prime of 2 greater than 0, positive, but the graph of the function at 2 is convex, therefore the graph should be negative. Therefore, this statement is wrong. It is the right choice. F prime of 1 greater than 0. F prime of 1 at 1, the graph of the function is increasing. Therefore, f prime of 1 should be greater than 0, positive. Question number 60. F is a function whose derivative is an increasing function. Sketch the graph of f where f prime of x less than 0. F prime of x less than 0, it means the function should be decreasing, either A or D, because B and C, the functions are increasing. Also, function f is a function whose derivative is an increasing function. Since the derivative is an increasing function, therefore the graph of f should be concave. So we neglect D and we choose A because the graph in A is concave, in B is concave. Question number 61. The graph of the function f of x equal -1 over x plus 2 is always dash in its domain, increasing, decreasing, concave, or convex. First, we find the critical value of this function, find the derivative of this function, the denominator times the derivative of the numerator, 0, minus the numerator times the derivative of the denominator, 1, over denominator square. Set it equals 0, then 1 over x plus 2 power 2 equals 0, cross multiplication, 1 equals 0, contradiction, there is no critical value for this function, and the derivative is undefined when x equals -2, but -2 is not within the domain of this function. Therefore, we find the sign of the first derivative before and after -2. Before -2, 1 over -3 plus 2, it is positive. After -2, 1 over 0 plus 2, also positive. Therefore, the function is always increasing in its domain. The right choice is A. Question number 62. Assume that f prime of x less than 0. What does that mean? That is mean the function is decreasing in the interval 1 to 8. Which is true. Since the function is decreasing, then x1 less than x2 give you f of x1 greater than f of x2. This is for decreasing function. Now we have 2 and 6. 2 less than 6, then f of 2 greater than f of 6. The right choice is B. Question number 63. Which one of the following graphs satisfied the condition? We have 4 conditions. Let us apply it for one by one graphs. For the first graph, f prime of x greater than 0 when x less than 0. When x less than 0, the function is decreasing, then f prime of x should be less than 0. Therefore, the first condition not satisfied, the first choice is not true. The second graph, f prime of x greater than 0 when x less than 0. When x less than 0, the graph is increasing, therefore f prime of x, it is greater than 0. F prime of x less than 0 when x greater than 0. When x greater than 0, the function is decreasing. The graph of the function is decreasing, therefore the derivative should be less than 0. Also, this condition satisfied. F prime of 0 is undefined. F prime of 0 also is undefined because the limit from the left not equal to the limit from the right. Therefore, from the left is 1, from the right is 2. Therefore, this condition is also satisfied. F of 0 equal to, as you see, f of 0, we have a gap at 1, but f of 0 is 2. All the conditions satisfied. B is the right choice. Let us see. f prime of x greater than 0 when x less than 0. When x less than 0, the function is decreasing. Therefore, f prime of x should be less than 0, not greater than 0. Graph 4, f of the 4 condition, f of 0, 2, but f of 0 is a gap here at 2, f of 0 is 0. Therefore, also this graph is wrong. The right choice is B. Question number 64 to 66, use the graph on the right to answer them. On which interval is f prime of x less than 0? F prime of x less than 0 when the function is decreasing, and this function is decreasing on its domain. Therefore, and its domain is from negative infinity to positive infinity. The right choice is B. On which interval f double prime of x greater than 0? F double prime of x greater than 0 when the function is concave, and it is less than 0 when the function is convex. The function is concave in the interval 0 to positive infinity. The right choice is A. 66. The value of the limit when x approaches to negative infinity of f of x. This is negative infinity. When x approaches to negative infinity, the graphs go to 2. Therefore, the right choice is C. Question number 67 to 70, use the graph on the right to answer them. Question number 67, on which interval is f prime of x greater than 0? F prime of x is greater than 0 when the function is increasing, and the function is increasing from negative infinity to 0 and from 4 to positive infinity. Therefore, 4 to positive infinity and negative infinity to 0, choice D is the right choice, A and C. 68. For which value of x is f double prime of x equals 0? F double prime of x is equal 0 at the inflection point, and since the graph has no inflection point, therefore not 0, not 1, not 2, it is none, the right choice. Question number 69, on which interval f double prime of x less than 0? F double prime of x is less than 0 when the graph of the function is convex. The graph of the function is convex on this interval from negative infinity to 2. Negative infinity to 2 is the right choice, C. 70. What is the graph of the given function? Which one of this function is the function of this graph? As you see, we have two given points on the function. Y-intercept here, 0, negative 3, and it is local maximum value for this function. And 4, 5, it is local minimum value for this function. All the four functions satisfy the y-intercept 0, negative 3, because if we substitute, except B, because if we substitute 0, every x with 0 in A, we get 6 over negative 2, it is negative 3. If we substitute 0 in B, 0 minus 0, 0 over negative 2, 0, it is not negative 3. This choice is wrong. If we substitute every x with 0 in C, 0 minus 0 plus 6, 6 over negative 2, negative 3, it is right. 0 minus 0 plus 6, 6 over negative 2, negative 3. But if we substitute the local minimum value of the function in the first function, we get 4 square, 16 plus 6, 22 over 2, 11. It is not 5. So this choice is wrong. 4 square, 16 minus 12, 4 plus 6, 10 over 2, 5. It is the right choice. Let us check here. 4 square 16 minus 4 12 plus 6 18 over 2 9. It is not 5. Therefore, the right choice is C. The last question, question number 70, by using symmetric intercepts, asymptotes, first and second derivative test, determine the function of the graph. We have two local extrema value for this graph. Here, 1, negative 2, it is local minimum value, and here, negative 1, 2, it's local maximum value. If we substitute this point in our functions, we get 4 over 2, 2. It is not negative 2, so A is wrong. Negative 1 times 1, negative 4 times 1, negative 4 over 1 plus 1 over 2, negative 4 over 2, negative 2, it is true. Let us check here. Negative 4 times 1, negative 4 over 2 plus 1, 3, negative 4 over 3, it is not negative 2. It is wrong. 4 times 1, 4 over 2 plus 1, 3. Also, this choice is wrong. The right choice is B. See you next lesson.